often for a beginner that's building a software, they don't think as much about tracing and logging because they're focused just on getting something to work. But it's really important to think about the tracing and logging because it's data science for production software. And that's really the best way to think about it is why do we care about data science like life expectancy or clustering to find new customers, etc. We care about it because it's a way to provide insights. Likewise, with software, if you deploy a bunch of microservices and they're getting invoked, let's say millions of times per month, how do you know what's happening without having some kind of logging, some kind of observability, some kind of distributed tracing so that you can coordinate the events that are occurring and then make insights as a result of those. So let's first define what is the difference between tracing and logging. This is a really critical one to get into. Logging is something probably people with Python have some experience with. You print hello world. That's a form of log. The problem though is that that goes to standard out. What you want to do is you want to capture those logs and put them somewhere and also have the ability to toggle between different levels. So let's say log.debug would be just for when you're developing or you're debugging something in production. Log.info would be a standard kind of log message that would give you some kind of feedback like talking to the database or customer transaction succeeded, etc. And then maybe a log.exception would be catching errors or log.error, etc. So it's important to know that logging really gives you another layer of protection beyond just printing something to standard out. So logging is a point in time event record. It captures discrete events without necessarily having a relationship. And also the traditional way people have logged in the past was unstructured or semi-structured, although we're starting to go a little bit more towards JSON logging, and also it's stateless. So each log line would exist independently, and things like application errors, state changes, those are the kind of things that you would put inside of a log. Now, in terms of tracing, this is a little bit different in that it's a request scoped observation across system boundaries. So it could map relationships between operations, or maybe it has timing data and parent-child hierarchies. It's stateful as well, so it's going to span the relationship between the different contexts. And also it could be, as an example, an end-to-end request flow. So let's say you're authenticating to a website or you're purchasing a good, or even having a cross-service dependency like grabbing a file and maybe shrinking the file and putting it into a thumbnail, etc. In terms of technical implementation, in logging, the basic levels that you'll come across would be error, warn, info, debug, and also there will be log aggregation as well. And typically you would add some kind of manual context as well. So this is where things like generative AI really is not useful because you have to actually know what's going on inside of your logging. If some tool created the logs for you, what context did it add? Did it add the context you want, or did it add some random context? So it's important to be thoughtful about putting the right context in a log statement so you can go back to it and see what's happening. Also, you want to have storage optimized for text search and pattern matching. In terms of tracing implementation, again, what's a little bit different about this is it's going to span operations with start and end times. Also, it's going to trace context propagation with headers or messaging data. And also, sampling decisions are made at trace inception. And then finally, storage is going to be optimized for causal graphs and timing. So some of the use cases for logging would be you want to debug something in isolation, you want to have an audit trail, or you want to do a really simple deployment architecture and you have maybe a resource constrained environment. Again, because you can toggle the different levels, that's one of the advantages of basic logging. For tracing, this is where maybe you want to get into the bottleneck identification for a production service, or even have distributed transaction monitoring as well. So if you have lots of different services that are being integrated, and also lots of different maybe serverless endpoints like Lambdas, how do you coordinate all of them together to find a meaningful transaction. Also, tracing is used for root cause analysis across service boundaries. So again, let's say you have 4 different microservices and 2 different databases. And also with tracing, it really plays in well with microservice and also serverless architecture. In terms of what are some of the new changes that are happening with modern logging and tracing, one of them is that there's structured logging now. We see more and more of an emphasis on JSON or structured formats so that you can have a easier way to do lots of things with that data. For example, build metrics. And then in terms of correlation IDs, this is critical as well. As if you don't have an ID, how could you possibly trace the transaction? So you need an ID that potentially would go across the entire request cycle. So the user logs in, then they go and they purchase an item, and then they get the item shipped, etc. You need to find that ID that links all 3 of those operations together so that you can figure it out. We also have the concept of unified observability. So OpenTelemetry is a good example where you would combine metrics, logs, and traces all together. Also, you could have context propagation, also these trace IDs to cross-reference things. So this concept of unified observability is also a very interesting component because, for example, you may want to look at the CPU load for something. You also may want to correlate that with the info or debug level logs. And then you also may want to have a trace level that shows what part of the transaction that was involved in. So really, these are different views, or almost like a dashboard inside of a vehicle where you have different monitoring that you would look at: the oil, the gas, the speed, etc. You're looking at things from a different perspective by having unified observability. So in terms of the technical considerations here as well, we have network overhead is going to be a lot higher for tracing. The storage as well is going to be a lot higher for tracing. And then the query complexity for tracing is also potentially very complex. Like you have to look through a graph and see how these things are coordinated with each other. And in a nutshell, the integration for tracing across different services does require a lot more effort. So again, if you need to link together some transaction ID across lots of different services, this is when people like to use these third-party tools that help you coordinate the different data points like New Relic or maybe Datadog, or maybe with AWS you have CloudWatch. So in terms of Rust here, what are some of the core ecosystem components? We have the log crate, which is really the de facto standard, and you can do an environmental logger or a simple logger, and you can have log macros like error, warn, info, debug, trace. So the idea here is that you can toggle between the different levels. Again, instead of just printing something as standard out, which won't be shown in production, you can do a log.debug and then toggle on that level when you need it. Tracing is the next generation type of instrumentation, and there are some things that you can do with the tracing crate, and you can do instrument, span, event, and you can also have different subscribers that will process that telemetry. So the big idea here is that with tracing, it's really spanning across an operation, as we talked about earlier. So really, what are some of the key technical things to be aware of is that with Rust itself, you're going to be able to go between log crate, tracing crate, and also there is integration with the async ecosystem. And you see this with Tokio in particular. You can see that Tokio has tracing built into it, console subscriber, also web frameworks like Actix Web has the ability to do automatic middleware for HTTP request tracing as well. So some of the things to be aware of when you're implementing these kinds of systems is, again, the transaction ID is critical. How do you link together all these events across the services? So really, to wrap things up here, there are a lot of different things to consider when you're doing production software, but one must have, not an optional have, is to have tracing and logging into your system, especially with microservices, so that you can use data science for production software engineering.